Hey everyone, and kind of thank you for kind of letting me take the opportunity to give you a little bit of a glimpse into work that AWS is doing around digital twins. Just a quick introduction. My name is Ashish Naik. I'm one of our senior specialists focusing on autonomous compute at AWS. And so my role is kind of to work with customers around innovative projects around digital twins and scaling simulation applications. So kind of what I would like to kind of cover today is AWS, how we kind of define our digital twins, and a leveling guide that I'm actually very keen to get feedback on from this community on, based on kind of what we built out for our customer interactions. Give a quick insight into some of the services that we've been working on, and a couple of examples. A lot of people kind of think, what does AWS care about around digital twins? And our goal is to kind of enable organizations really with kind of the digital twin foundational infrastructure to create the digital twins and really kind of provide that foundation that enables builders and partners. So it's always best to kind of start, I find, with an example. So we worked with an organization called MHP. They're part of the Porsche organization, and they wanted to create an electric vehicle digital twin of the battery health and performance of an electric vehicle. We all kind of know that the range of the EV is something consumers kind of really care about. And this is actually very dependent on the driving style of an individual and also the specific vehicle characteristics and the battery health. And so the goal was to be able to update a specific digital model of the battery that was specific to the user and be updated with operational data, with field data, to continually update those model parameters. And the goal was to essentially increase the individual's model accuracy as they kind of get more used to their car and things like this. And so the idea of this would, once it would be deployed in production, will give them the ability to dramatically enhance the user experience by providing highly accurate estimations. And so kind of how does AWS view digital twins? Well, I think we kind of look at digital twins always got to have four components. It's the digital representation, it's the physical system, it needs to be dynamically updated and connected, and it has to kind of drive business outcome. And so through all of the kind of time we spend with our customers talking about digital twins, what we've tried to do is try to categorize or create a leveling index to define what type of digital twin our customer is going to do. And so there are links to some blogs that I'd actually love feedback on from this community. But we've kind of created a leveling index that covers four kind of core areas. The number one is the L1, it's the descriptive digital twin. The L2 is an informative. L3 is about prediction, and L4 is around kind of a living representation of a living digital twin. So an L1 would be kind of focusing on the engineering design, visual representation. So a lot of the kind of work that we see around kind of building information or BIM or large complex 3D VR models, these are kind of fairly descriptive. It shows the design of the physical system. The L2 digital twin is where we integrate IoT, sensor data, maintenance data, to kind of really give us a understanding of its present condition. And then L3 and L4 is about kind of predicting the what if of the future. So the L3 really does this based on predictions, or using kind of predictive modeling, the historic data to understand what a future condition could be. An example of this is, quite commonly is predictive failure rates and anomalies in things like rotary machines. And the L4 digital twin for us is where, the model is continually being updated, and multiple models within this are being updated based on continual new data that the system is going to be being provided with. And so AWS has kind of capability across all of these areas. But really quickly, let me just show you a couple of examples for L2 and L4 specifically. So if I look at an L2 digital twin, this is, the core challenges we hear from our customers needing to be able to bring data in from different sources, model it, and kind of create effective visualizations. So here is a quick example you'll see of a factory that we built within our IoT Twin Maker that allows us to add in kind of different assets, allows us to actually kind of visualize how the factory will look, but also create dashboards with real data, videos that allow us to kind of have complete informative information of how our digital twin is kind of operating. The next kind of example I want to talk through is about the L4 digital twin, this kind of living digital twin concept. And so all these digital twins have four core components. They have sensors, IoT connectivity, modeling, and at-scale simulation, at-scale computation. And all of these are going to be digital kind of trends that are now culminating that allow us to kind of create these digital twins where we're using continually new modeling techniques such as predictives, Bayesian models, machine learning, and AI to continually have our digital twin get closer and closer to the reality of what we see in the real world and give us better futuristic predictions. So an example of this is some work that we were doing with Siemens Energy, for example, where we could actually use different probabilistic modeling techniques to actually enable them to reduce their downtime by about 60% for a heat recovery steam generation. So, and then another quick area that we're starting to kind of explore is about how we scale the simulation, and kind of the work that we just saw from the Red Hat presentation links kind of quite nicely to this. And so when we talk to customers around the need for simulation within their digital twin, they find that the simulation is limited by the amount of computation that is available to them. So we've been working to create services that allow them to scale this kind of computation in specific areas such as traffic simulation, urban planning, and disaster recovery. And so just kind of a last quick example was an example where we were trying to do a large scale city modeling using kind of simulation to actually see how the simulation of over 1 million people would actually impact a particular city, in this case, kind of Las Vegas. And the goal from AWS was to provide infrastructure that would allow people to scale their kind of usual small, complex simulations at the micro level, but to really be able to scale that across the macro and micro environments to the point where we could add in, GSI information to actually look at, sections, what would happen at particular infrastructure, etc. And so part of this was about enabling scale of simulation. So last kind of slide, kind of before I kind of hand back, is how do we kind of engage, and what's our role to kind of support innovative projects? Our goal is to kind of support customers through kind of discovery discussions, really learn about the digital twin that you're trying to create, try to decide where it fits in the leveling framework, and then work with you to kind of build out technical validations, proof of concepts that can ultimately be deployed in production as you need. But we're here as a supporting entity to kind of support innovative digital twin concepts that people want to kind of bring to market. So with that, I'll kind of hand back to the team for kind of questions and comments.